Game.
Wind turbine.
Okay.
Wind turbine. The next. Wind turbine is a type of renewable energy that harness the power of wind to produce electricity. The basic idea is that wind turbines uses rotor which with attached blades to collect wind's potential and kinetic energy. Wind turns the blades which spins a shaft that is connected to a generator which results in generation of electricity. A large number of wind turbine is also called a wind farm. Yan yung mga parts of wind turbine. The pitch, yung parang sa may harapan. Rotor, yung pinaka, tawag doon, parang nakabit sa may blades. Then blades. Low speed shaft, yung sa may gitna. Gearbox, generator, controller. Anemometer, wind vane, nacelle, high speed shaft, brake, yaw drive, yaw motor, and tower. Okay, next. Yun lang rin yun. Yung parts lang din siya na. Parts and function. Blade. Okay, so may blade muna. The blade is the part of that relates due to the force it catches from wind. It is connected to the low-speed shaft via the hub. The low-speed shaft is connected to the gearbox, and the gearbox to the generator. Once the blade rotates, it causes the rotation of generation, thereby generating electricity. Most wind turbine consists of 3 blades for maximum efficiency. So yun yung tinatamaan ng hangin, no, yung blade. Ayan, yung nakita naman doon yung blade. Pag umikot siya, no, masama niyang makapaikot din yung gearbox, and then yung tawag doon, pag napaikot niya yun, mapapaikot din niya yung generator na mag-generate ng electricity. Okay, next. Blade design. To produce an amount of power, wind turbine blades generally need to be large and tall. It is shaped to generate the maximum power from the wind at the minimum cost. Improvements in the design has produced new wind turbines which are more compact, quieter, and generates more power from less wind. Its length at around 50 meters, which 107 meters currently the longest from Siemens Gamesa. Ito yung pinakamahabang wind turbine sa mundo yan yata yan. Anyway, haba nung ano. Okay, next. Parts and design. Blade design. So, kailangan may design din. Airfoils is the cross-sectional shape of the blade that determines its aerodynamics. They are key to the two-blade design. This airfoil design allows the blade tips of the wind to move faster than the wind is moving, thus generating more power and higher efficiency. So, kaya merong blade design para mas efficient, mas tawag doon, mas madaming ma-generate na electricity, mas ma-harness yung power ng wind ng mas maganda. Tawag doon, yung pagkakaayos niya, no, yung pagkaka-style nung pinaka-blades, no, ng mga blades. Yun yung mag-determine gaano siya ka-efficient. Okay, next. Airfoil design. Ayan, iba-iba rin yung mga airfoil design nga. In airfoil family for medium blades and tip region airfoil, 95% radius. Ayun, okay, nakita naman, parang merong mga hindi masyadong naka-curve. Merong yung isang halos side lang niya yung naka-curve. Iba-iba. Ayan, primary outward airfoil, 75% radius. Root region airfoil, 40% radius. Tapos mga thick airfoil family naman for large blades. So, pang malaking blades. Tip region airfoil, primary outboard airfoil, tsaka yung root region airfoil. Ayun, so, may malaki ng curve sa ilalim. Okay, next. Blade aerodynamics. Ayan. Parang kanina lang rin. Wind turbine blades work by generating two aerodynamic forces, lift and drag. This is due to wind and their airfoils. Lift force is perpendicular to the airflow and is in the line with is in line with blade rotation. Drag force is in line with apparent wind direction, which is in opposition of the blade motion. Drag increases in proportion to the frontal area of an object facing the wind. Kaya meron nga tawag doon, merong blade design para doon. Okay, lift and drag formula, yan. Sa lift and drag formula, ayan, yung lift, yung formula dyan is coefficient of lift, yung, ayan, yung parang CL. And then, wind density, yan, wind density yung parang P. Then, wind velocity, yung V, and then area of the blade over 2. While yung isa naman is yung drag, yun niya sa baba, is coefficient of drag, no? Times na may wind density ulit, then wind velocity, then reference area over 2. Okay, next. Yan, portion design. Yan lang rin yun, yung kanina ay another thing that the airfoil is able to bring is for the blade to attain difference in pressures on both sides. The most curved side, or we may say the convex side, generates low air pressure, while high pressure air pushes on the less curved side. Or we may say the side with slightly concave part. This is actually the reason of blade rotation. Okay. Ayan, aerodynamic wind orientation. Here's now the question based on the figure showing the optimal angle of attack. Which of the blade is the leading edge and the trailing edge? No, ang leading edge dyan is halos yung taas naman. Okay, next. Blade rotation. What will be the rotation of the blade? Ano yung rotation? Based dyan sa mga tawag doon, sa pagkakaayos sa may blade na aerodynamic. Is it push to the side that has more curve or push to the side that has less curve? Kaya sagutin natin mamaya. Okay, next. Aerodynamics. Ayan. This photo shows the front side and the back side as well as the leading edge and trailing edge of the blade. Ayan, makita naman sa blade ay may mga naka-curve pa. Next. Parts and design. Blade design. In addition to its curved design, twisted and tapered blades further enhance its aerodynamics. So, mas efficient. With the combined effect of twisting and tampering the blade along its length improves the angle of attack, increasing speed, efficiency, and lift while reducing drag. Number of blades. Here's our question. Based on the previous slides, what number of blades is the best design in consideration with of all the factors in construction and operation of wind turbine? So, kung mapapansin nyo, siguro obvious naman na yun, kung mapapansin nyo, most doon sa mga wind turbines na makita nyo kanina sa mga pictures, ang pinaka number of blades na pinakamaganda is 3. Na banggit na rin kanina doon yun, nakalagay na. Okay, next. Subordinate rear back curve. Ayan, number of blades. Ayan. Blade is curved more than the front. This part shape causes pressure differential when air moves across the blade, which is what causes the blades to move. Because of the obstruction of the blade, air moves at a faster velocity behind the blade than in front of it, which is what sets the rotation of the blades in motion. Engineers must consider speed and drag in designing the blades to ensure the highest level of efficiency. For example, if too much drag is created by the obstruction of the blades, the power yield would be a lot lower. If not enough drag is created, the blades could move too quickly, causing them to break the sound barrier. So kailangan lang yung parang middle point niya, kung saan lang siya sakto. Kasi ngayon nga, pag masyadong malakas yung drag, ito yung mahina naman. Mahina lang may generate na electricity. Pag sobrang bilis naman, potentially at risk na yung tawag doon, yung wind turbine na yun kasi napakabilis. Wala parang masyadong nagpapabagal. Baka masyado umikot, masira naman. Okay, next. The rule of thumb is the pure the blaze, the better since there will be less drag and increase in efficiency. Yan nga, kaya hindi kailangan sobrang dami, hindi sobrang konti. The number of the blades increases the torque and reduces the optimum rotation speed. Having pure blades reduces drag. Okay, next. number of blades. One blade, because of the decreased drag, one blade would be the optimum number when it comes to energy yield. Yan, kung energy yield, no, isang blade yung pinakamaganda. However, one blade would cause the turbine to become unbalanced kasi isa lang eh. Hindi ano tawag doon. Kumbaga, may weight lang siya sa isang point. Wala siyang equal weight sa kabila. Kumbaga, hindi balance. And this is not a practical choice for the stability of the turbine. Parang mas prone siya sa pagkasira since hindi nga stable. Next. Two blade. At first glance, two blade turbine seems like the optimal configuration. Mukha siyang pinaka-optimal, pinakamaganda, perfectly balanced kasi nga meron na parang equal na, dalawa na eh. And with one blade less than three-bladed turbine, they will generate less drag. So why aren't all turbines made with two blades? Ito yung reason. It has troubles in yawing. Yaw is when its head or nacelle turns to face the wind due to an effect called gyroscopic precession. When a two-blade turbine yaw, it creates a wobble as the blades go from vertical plane to the horizontal plane, which places additional stresses on the mounting bearings, wearing them down faster. So parang mas mabilis naman siyang parang doon. Di naman parang masira, parang similar lang doon, pero mas mabilis siyang ganoon. Maganon compared sa mga three-bladed most likely. Okay, next. More than 3 blades. Any number of blades greater than 3 would create greater wind resistance. Meron na mas malaki na yung wind resistance, mas malaki na yung parang drag, slowing the generation of electricity and thus becoming less efficient than a 3-blade turbine. More than 3 blade, yan nga yan. Next. 3 blade. For this reason, turbine designed with blades are the ideal compromise between high energy and greater stability and durability of the turbine itself. Yan sinabi ko na umpisa, 3 blade yung pinaka efficient, pinaka maganda. Okay, next. Parts and function. Blade tilting mechanism. And nakita naman dyan sa may picture. According to the wind speed, the relative velocity angle of the wind also changes. A blade tilting mechanism is a sensor coupled parts of the wind turbine which tilts the blades and guarantees a proper alignment of the blades with the relative velocity so that its position is always at its optimum angle of attack. Parang inaan lang niya sa kung saan sa may wind speed sa sa may pinaka-wind direction, pinakatama ng wind. Doon nag-a-adjust siya doon para mas maging optimal yung pagkakakuha ng pag-generate and pagkukuha ng ng wind energy. Next. Parts and function na nacelle. The housing of the back of the blade which contains the slow speed shaft, gearbox, generator, and other small parts inside it. Ayun na nga, doon siya, parang doon nakastore yung mga yun nga, gearbox, generator, and other small parts. Next. Gearbox, the component which converts the slow rotation of the blade into faster speed. So, ayun, yung 'di ba, merong una yung blade may parang mahaba na magpapaikot, nakakabit yun sa gearbox. Yung gearbox naman, yun yung parang imbes na mabagal lang yung ikot ng ng wind. Yung gearbox yun yung parang nagpapadami ng rotations, nagpapadami ng nagpapabilis. This is needed simply because the rotation of the blade generated from the force of the wind is usually not enough for a generator to achieve a grid quality voltage output. Yun nga, kulang siya. Most generators need to be turned at 1,500 rotations per minute for 50 Hz and 1,800 rotations per minute for 60 Hz. In no way it is feasible for turbine blades to move that fast. Kaya nga, may linagyan siya ng gearbox. Next. Gearbox. Ayan, yan yung gearbox. And kita na rin yung mga mga parts. Main bearing, main shaft, planet stage, LSIS stage, HSIS stage, HSS stage output to generator. A common ratio is about 90 to 1 with a rate of 16.7 RPM input from the rotor to 1,500 RPM output for the generator. Next, direct drive gearless. In a direct drive turbine, there is no gearbox. Walang gearbox. The main shaft spins the generator directly, causing it to spin at the same speed as the turbine blades. Comparing to gear type, the slow rotation and decrease is moving parts of PMDD generator reduces fatigue and stresses on the turbine, resulting to uh, reduce noise and vibration, longer lifetime, and lower cost of maintenance. Siya yung alternative design, yung wala naman siyang wala siyang gearbox. Next. Yan, isa pang direct drive naman. So, an important fact is that due to wind inconsistency, the gear type turbines often operate at partial loads. The efficiency of the PMDD generator excels even in these conditions because it continues working nearly to nominal values. This design makes suited even in offshore wind application. Next. Okay, ulit. One main disadvantage of PMDD is that to make up for its slower rotation, more magnets are added to create the required frequency and power. This increases the diameter of the generator, which makes it larger and often heavier than geared type wind turbine. So mas mabigat, no? Mas nilagyan nga ng madaming ng magnets. Net. Another thing is that the additional magnets, ano ba? Ayan. Another thing is that the additional magnets being used in this type is made up of neodymium, which is expensive, so magastos pa. Okay, next. Next. Yeah. The cost and weight of the direct drive turbines have prevented it from presenting major competition to the gearbox turbines until recently. But other experts claim that that direct drive technology will eventually become the dominant one. So possible ito na mag-offer. Since the gearbox wind turbine is almost at its maximum efficiency point. So parang yun yung pinaka-improved state niya, yun yung pinaka magandang design, gano'n. While the PMD generators have more possibilities for improvement. Ito naman, parang pa lang, in-experiment pa lang, pwede pang mas ma-improve, mas pwedeng mas higitan yung gear type na gearbox wind turbine, no? Okay, next. Force and traction brake. Ayun, brake. The brake system in wind turbine is a protective device coupled with sensors which automatically stops the rotation of the blade whenever it detects activities that could harm the system during operation. Ayun, yun yung mga possible na makakapag-harm. Very high wind speed, vital parts not working, maintenance in power lines, and others. So, kusa siyang gumagana na nagbe-brake pag meron ng mga ganun. Next. Yaw system, yan, yaw system, is sensor-equipped mechanism consisting primarily of yaw motor, yaw drives, and others. Its function is to automatically rotate the nacelle on top of the tower so that the set of blade is facing the wind directly at times. It detects ano, it detects proper direction through the electronic information being fed by the wind vane located at the back. Yung wind vane yung parang pa-triangle sa nasa likod, yung pinaka nasa likod. And this ensures that the wind turbine is producing the maximum output of electricity. Yun yung parang nagro-rotate na gano'n para tatapat siya sa pinaka direction ng wind. Next. Tower, ayan tower yung parang malaki lang. Wind velocity increases at higher altitude. So mas mataas, mas malakas yung hangin. This means taller tower, the greater electricity it can produce. Majority of wind turbines are supposed by conical tubular steel towers with a height of usually 75 to 100 meter, about 250 to 370 in feet. Depending on the blade's diameter, the tallest is still for completion in the mid of 2022. So 2022, ngayon na rin yun, mid, which is 280 meters. Parang yun, no? Parang almost triple nung usual na laki. to be installed at a test center in Western Jutland, Denmark. Sa Denmark. Okay, next. Tower and blade diameter ratio. Ayan, nakita lang naman yung mga ratio. Yung parang ano niya, yung advancement, yung pag-improve niya through the years. Ayan, sa year 2000, average hub height is 58 meters, average rotor diameter is 48 meters. No 2005 naman, 75 yung height, 65 yung diameter. 2010, 80, diameter 84, eh, parang mas tumalaki na yung yung diameter. Lumalaman na kaysa height. Then 2015, 82 yung height, 102 yung diameter. And noong 2018 naman is average is 88 naman sa height meter and then 116 sa diameter. Okay, next. Ideal location. The best places for wind farms are in coastal areas. So yung parang medyo malalapit sa mga tawag doon. Tawag doon, yung medyo malapit lang sa may madagat magan or mga tawag doon. Basta malakas yung hangin and tulad ng rounded hills, open plains, and gaps in mountains. Yung parang pinagdadaluyan talaga ng hangin or doon talaga dumadaan yung hangin. Places where the wind is strong and reliable. Some are offshore. To be worthwhile, there should be an average wind speed of around 25 km per hour. So, kailangan gawin kabilis para uh, efficient, no? Yung pagkakapesto, yung location nung paglalagay ng uh, wind farms. Okay, next. Powers and yan, disadvantages ng yan nga, mga wind farms. Ayan, wind is free. Wind farms need no fuel. So, free. Produces no waste or greenhouse gases kasi ang ginagamit nga lang wind hina-harness lang yung wind. The land beneath can usually still be used for farming kasi linagyan lang naman. Kung tatanggalin yun, magagamit pa rin. A good method of supplying energy to remote areas. Disadvantages naman niya is the wind is unpredictable. So, di mo masabi kung malakas ba, kung o hihina, ganun. Mahirap sabihin, mahirap i-predict. Suitable areas for wind farms are often near the coastal area where land is expensive. So, magastos. No, ha? Tsaka, kailangan pipili ka lagi ng mga nasa coastal area. Can affect television reception on nearby places. So, nakaka-affect din sa mga TV. Kung yung TV reception. Okay, next. Largest wind farm. Yan. Gansu Wind Farm, about 7,965 megawatts sa China. Alta Wind Energy Center, no, sa California, USA. Mupandal Wind Farm sa India. Hornesa Project 1 sa UK. Mark Big Den Wind Farm sa Sweden. Jaisalmer Wind Park sa India ulit. Okay, next. The Gansu Wind Farm or Jikwan Wind Power Base is a large group of large wind farms. So madaming wind farms under construction in Western Gansu province in China. In 2008, constructions began uh, began ay nasa ba? Began of a 750 kilovolts AC power line to carry electricity for a wind farm, and construction of the wind farms themselves started in August 2009. In November 2010, officials announced the completion of the project's first phase involving the installation of over 3,500 wind turbines with an installed uh, capacity of approximately 5,160 megawatts. It has an estimated cost of 120 billion Chinese yuan. About 17.5 billion dollars. So napakamahal. And then the project is being built by more than 20 developers. Okay, so I think sobra naman na ako. So, Jerome?
Lakas na tawa mo, ano ka? Ano ba dito sa Burgos?
Yan.
Okay, Burgos Wind Farm. The 150 megawatts Burgos Wind Farm is the largest wind power project in Southeast Asia located in Burgos in Ilocos Norte. So, masabi na rin natin na yan yung naging main wind farm dito sa Pilipinas kasi halos wala namang ibang wind farm dito eh. Then the estimated cost for the construction of wind was 450 million US dollars, which has completed in 2015. It is located within a 600-hectare site. The facility consists of 50 wind turbines, each with capacity of 3 megawatts, generating electricity to the Luzon grid. Each wind turbine rests on a tubular steel tower that has a 75 meters stub and a height of in a height and a 90-meter rotor diameter. Next. So the grid operation. So ang makikita na natin is, ayan, papasok yung wind or sasalubong yung wind, sasalubong siya ng windmill, then the rotor blade, which is yung magpapaikot sa gearbox. And then yung uh, generator is magge-generate siya ng electricity, which is dadaloy siya patungo sa power cables inside tower and then sa transformers, which ano naman magkakaroon ng transfer to switchyard. Next. Then the hydrogen power plant. A hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electrical energy. So yung hydrogen power plant, oh my. So yung hydrogen power plant daw is concept design siya para sa bagong uh, source ng electricity. Next. So working principle. So basically yung hydrogen power plant daw is like a batteries. It is large tanks of liquid hydrogen go, uh, go feed into thousands of hydrogen fuel cells. And their fuel cells are solid structures containing an electrolyte fluid and two terminals. Then the reactants flow into the cell, in this case hydrogen and oxygen. They intermingle with the electrolyte to produce an electrical charge and water as a byproduct. The water flows out another part while the electricity is siphoned off the terminal and held in a gigantic multi-ton batteries. The electricity resides in batteries until it is needed, in which case it is sent out through the local power grid just like any other types of power plant. So next na tayo. So battery parts and functions. So number one is the electrolyte, which is a chemical compound that conducts this electricity by changing into ions. It is a it can be a liquid or a paste-like substance. Some of the examples are ammonium chloride, zinc chloride, potassium hydroxide, lithium, phosphorus sulfide, and sulfuric acid. Then anode naman, ito yung negative or the reducing electrode. So in the cathode will be the opposite of the anode, which is the positive now, or the oxidizing electrode that acquires electrons from the external circuit. Example ng anode is zinc, metallic, lithium, and lead. And the example naman ng cathode is manganese dioxide, carbon dioxide, and copper. Next. So battery, the schematic diagram. So ito yung schematic diagram niya, which is nakita mo natin yung solution, electrolyte solution, which is merong anode and the other side which has the cathode. From anode, dadaloy siya generate ng electricity papunta sa cathode. Next. So this is the construction of battery. So, well, meron tayo dyang metal cap which is positive. Then the carbon rod. And the zinc case, manganese oxide, o yung substance nga, moist paste of ammonium chloride, and then the metal bottom, which makes it the negative side. X. So how it works? There are a couple of chemical reactions within the battery. At the anode, the electrode reacts with the electrolyte in a reaction that produces too many free electrons. So as a result, these free electrons repel each other and try to go to the place with fewer electrons. So magkakagulo daw yung mga electrodes na nakakawala. And hahanap daw sila ng lugar kung saan may konting electron. Meanwhile, at the cathode, another chemical reaction occurs simultaneously that enables that electrode to the cathode. But the separator keeps the electrons from going straight from the anode to the cathode within the battery. When the circuit is closed or a wire is connected to the cathode and the anode, the electrons will be able to get to the cathode. Next. So the chemical reaction in zinc carbon battery. So in cathode or the manganese dioxide, meron sa electrolyte yung ammonium chloride. Then the overreaction in the cell is Zn plus 2MnO2 to ZnO plus Mn2O2. Then the exact mechanism for this complicated, and there is still controversy over the exact mechanism. However, the approximately half. Then the anode is Jn2 Jn squared plus 2E or 2 electrode. Then the cathode is 2NH4 plus 2MnO8 plus 2E, 2M2O3 plus H2O plus 2N3. So another chemical reaction is ammonium ion produces two gaseous products, the 2NH4 plus 2E. These products must be absorbed in order to prevent build-up pressure in the vessel, occurs by two mechanisms. The ZnCl2 plus 2NH3 to Zn times NH3 to Cl2. Next, hydrogen fuel cell working principle. So ang hydrogen fuel cell daw is yung H2 is papasok siya sa anode, and then meron siya parang pupunta sa catalyst kaysa isang part na to and may catalyst na proton exchange doon. Then meron lalabas na H2 na recycling na. Same with the cathode. Then meron sa gitna ng proton exchange membrane which separates the two. Next na. Hydrogen fuel cell working principle. Fuel cell work like batteries, but they do not run down or need recharging. They produce electricity and heat as long as fuel is supplied. So yung fuel cell daw is parang battery. Hindi raw siya kailangan paandalin or kailangan ng recharge. Hindi na raw niya kailangan yun. Nagproproduce ng electricity and heat as long as may fuel daw. The fuel cell consists of two electrodes and a negative electrode or the anode the positive electrode, which is the cathode, sandwiched around in an electrolyte. The fuel, such as hydrogen, is fed to the anode, and the air is fed to the cathode. In a hydrogen fuel cell, a catalyst at the anode separates hydrogen molecules into protons and electrons, which take different paths to the cathode. The electrons go through external circuit, creating a flow of electricity. The protons migrate through the electrons to produce water and heat. Next. No?
Wala ano.
Okay na, next.
So hydrogen fuel cell, the working principle. Fuel cell works like batteries, but they do not run down or get charging. Ay, ito na yung discuss ko kanina eh. Hydrogen fuel cell, the working principle summary. Hydrogen atoms enter at the anode, while the oxygen is fed to the cathode. So the hydrogen atoms are separated into protons and electrons at the anode with the use of platinum catalyst. The now positive charged protons possess through polymer electrolyte membrane, also called as a proton exchange membrane, heading to the cathode. With, ano daw, yung charged protons daw ay tawag doon, pupunta sila sa cathode. Then the polymer electrolyte membrane or the PEM is especially treated material that looks something like ordinary clips in plastic wrap. It only allows positive charge ions to pass into while it blocks the electrons. The free electrons travel through a wire creating electric current. After passing through the circuit and the membrane accordingly, once again, with the aid of platinum as catalyst, the electrons and protons of, uh, meet of the cathode were as byproducts. Next. So ito yung schematic diagram. Yan. Kaya nakikita natin is yung H2 is papasok through pipeline, which is nag-supply mula dito sa delivery. And then yung H2 is magta-travel siya papunta ron sa hydrogen FCs. Yan, mag-spread siya ron. Same with the oxygen. Pupunta siya dito sa isang container, then magta-travel din siya and i-spread niya sa hydrogen. FCs. Which is mag-produce naman papunta sa magpo-produce sila para magkaroon ng warm water. Same with the management unit. Kaso naman, dito naman is magpo-produce naman sila ng electricity. Pupunta naman sila sa AC or DC inverter and then through the grid transformer papunta sa local electric grid. Then the hydrogen FCs, pwede rin sila mag-produce ng heat para mapunta rin sa AC DC inverter. And same as the management unit, mapupunta rin siya sa grid transformers which can power up the local electric grid. Next. Why explore it? Fuel cells have several benefits over controversial combustion. A conventional combustion-based technology is currently used in many power plants and passenger vehicles. So hydrogen is very efficient fuel source, capable of producing more energy per pound of fuel than gasoline. This means an equal size tank of hydrogen fuel would give a vehicle a greater range or more powerful than when filled with gasoline in an internal combustion engine. So yung fuel cell is which is from the fuel cells more energy than ginagamit natin gasoline. So fuel cells have much lower emissions than combustion engines. Hydrogen fuel cells emit only water. So eco-friendly na rin siya. So there are no carbon dioxide emissions, no air pollutants that create smog and cause health problems at the point of operation. Also, fuel cells are quiet during operation as they have fewer moving parts. Next. why hasn't gone stream? So first is the hydrogen production through methane. About 95% of the hydrogen used today is produced by a process called stream reforming. Separating hydrogen atoms from carbon atoms is in methane. This process is expensive and it releases greenhouse gases which contributes to global warming, thereby canceling out any benefits to the environment. So in out of question nila due to uh first ano siya expensive siya, and then second is mas marami daw na nare-release na greenhouse gases compared to gasolines. Next is the hydrogen product through water. The other production method is electrolysis, which separates hydrogen from water. The downside is that it's expensive. So again, expensive na naman siya. Siyempre, nasabi natin expensive. So dalawa, the, the, the next will be the cost. The cost of the fuel cells can be high given the use of platinum as one of the largest component materials. However, there is a work underway to the non-platinum catalyst approaches. Next. So next is the hydrogen storage. So hydrogen storage, nagsastruggle pa rin daw yung mga scientists kung paano lang ma-store yung hydrogen. Oops. Okay. Brad, nakaharang. Okay mo. So, ayan, hydrogen storage. So, meron daw mga scientists na nag-struggle pa rin sa pag-store ng hydrogen because it has a, it is has such a low energy density. Hydrogen needs to keep under strong compressions to be a viable fuel source. As I said, necessitating strong tanks and heavy-duty fueling lines, as there is currently no mainstream system of storage and distribution for hydrogen fuel. So, why hasn't gone mainstream storage nga raw? Wala pang kumbaga completely magka-harness sa hydrogen. Next is hydrogen leak. Hydrogen leakage can occur during many steps of its production and use. Science magazine reported in June 2003 that hydrogen leakage from widespread use of hydrogen fuels would go up ozone faster than CFCs do. So yung leakage daw niya is sige. Latest development, the Long Range Energy Generation Project, touted as a first of its kind power plant in the United States. A long range energy generation project, a 485 megawatts facility being equipped to run a mix of natural gas and carbon-free hydrogen is nearing completion at the site of a former aluminum smelter on the banks of the Ohio River. The facility first will burn a fuel blend that includes 5% hydrogen in a General Electric Corporation H-class gas turbine. The plant is intended to transition to 100% green hydrogen over the next decade by relying increasingly on renewable energy to power electrolysis machines that split water into hydrogen and oxygen elements. Next. So this is the latest development, the CSMN energy. Construction begins on world's largest green hydrogen power plant, which is part of the unique basis load of solar project. So connected daw siya in unique base of load solar project. Siemens Energy will operate the units in the unique 170 meters 170 million pound euros facility. It is a remote part of French Guiana, which provide 10 megawatts of power during the day and 3 megawatts at night. A unique baseload renewable project that combines the world's largest hydrogen power plant with a 16 megawatt machines for electrolysis of hot water. A 3 megawatts fuel cell, 500 megawatts of solar panels, and 20 megawatts per or 238 megawatts per hour of batteries has begun construction in French Guiana. Next. Okay, tapos na.